Hey, hello everyone. Today we will look into relationship between two canonical forms, sum of minterms and the product of maxterms. So let's look at the first example. We have a three-variable function x plus x prime y. We're going to expand this function into sum of minterms using minterms method, and then product of maxterms using maxterm method. And then we'll look at the solution. I look at the answers, and then we're going to figure something out. Okay. All right. So let's look at this minterm method. So minterm method expansion will use the following. We're going to use our operator axiomat, which is a plus a prime is equal to 1. That's what we'll use. And we're going to use the first distributive law. That means the yellow highlighters will be for minterms expansion. Red highlighters will be used for maxterm expansions. Okay, let's go back to our example. So minterm expansion. I'm going to do the following. We have two terms, x and x prime y. Neither of them is a minterm, because minterm is product of all variables of the function. And we have three variables, x, y, and z. This one is only one variable, x. So let's expand it into y and z. This is how we do it. Let's look at this. So we're going to do the following. This function will be equal to x. We're missing variable y. So we're going to multiply x times 1 in form of y plus y prime. Okay. So as you know, a plus a prime is equal to 1, so y plus y prime is also equal to 1. So what I basically do is multiply x times 1 plus x prime y, and missing variable is z, so I'm going to multiply times 1 in form of z plus z prime. Okay, so I'm following up on this, and this is equal to x. I'm voiding the parentheses, xy plus xy prime plus okay. Now let's look at this expansion. We have four terms. 1, 2, 3, 4. Term number 3 and term number 4 are minterms because they're a product of all three variables. Term number 1 and term number 2 needs expansion into z. Z is missing, so let's expand it. Let's expand it x, y, z plus z prime plus x, y prime. And I'm going to copy this. Okay, let's expand it. Now we're going to follow this parenthesis. Follow the parenthesis z plus z prime and z plus z prime, and we'll figure out what minterms are this. So it's x, y, z plus x, y, z prime. We'll do the same with second, x prime y, x, y prime z. I'm copying term number 3. And term number 4. Okay, so now it looks like all the terms are minterms. We have to recognize which minterm is which. Okay, according to binary method, we're going to do the following. Let's change this to red. According to binary method, we'll do the following. If the variable is unprimed in a term, we're going to put 1 over it. If variable is prime, we're going to put 0. This is 1, 0, 1. This is 1, 0, 0. 0, 1, 1, 0, 0. Okay, you don't have to actually put it with the pen. You just have to remember that if the variable is unprimed, you put 1. So this xyz is 1, 1, 1. And guess what? In binary, 1, 1, 1 is 7. Let's change it. Look, binary is 7. So that is minterm 7. Lowercase m denotes minterm. That's minterm 7 plus xyz prime is 1, 1, 0. In binary, 1, 1, 0 is 6. And 6. You have to know your binaries. Plus x, y prime, z is 1, 0, 1 is 5. And 5. Plus, this one is like m4. M4. Yeah. This looks like m3. And this looks like m2. Alright, now we're going to put it in canonical form. That is equal to sigma. So all those sums, see all these sums, m7 plus m6, we're going to put it in canonical form. Sigma means sigma means addition, right? So it means sum. Sum of all those terms. So sum, and we're going to list the terms 2, 3, 4, 5, 6, 7. All right, let's see if it actually matches our answer. So, sum of 2, 3, 4, 5, 6, 7. Here we go. That means this function, x plus x prime y, can be expressed in this format. This format is called algebraic format, and this one is canonical format, sum of minterms. This format is used when this algebraic format is used when we build a circuit using basic gates like AND gate, OR gate, NAND gate, inverter. We need this format because we need the relationship between variables. This format, right? This one is called the canonical form. We use it when we use a little bit more advanced microprocessors like multiplexers or adders. Okay, then you cannot use, if you use multiplexer or you use adder, you use what else? You use encoder or decoder. You need this format because you're sending minterms instead of variables. Okay, so if you send minterms to decoder, you need to know which minterm are you sending. Here you don't see the minterm. Here you do. Okay, that's why it's important to know which one do you want? Do you want algebraic or do you want canonical form? Okay, Maxterm method. The same function, x plus x prime y. Okay, so the function is x plus x prime y. We're going to use a second distributive law to break up the product. All right, here, as you see, there's the following. So there's a term and there's a product here. So the variable and the product. And if we look at this, we have the following distributive law: term or variable and product. And we can break up this product right here. Okay? B goes to the first parenthesis and C goes to the second parenthesis. That's exactly what we're going to do here. And A goes to both parentheses. All right, so let's do it. So my A is x, and my B and C are x prime and y. So I'm going to have two parentheses. My term, my first variable, goes to both parentheses, right? And then this term, this product, right here, is broken up into x prime goes into first and y goes into second. Here we go. All right, now we have x prime plus x. X prime plus x is equal to 1. How do I know it? Because I can read right here, a plus a prime is equal to 1. That means variable plus its prime is equal to 1. So this one is equal to 1. So we cross it out, we put 1 here, and we're left with x plus y. Okay. Now, we're turning this function into max terms. And max terms are sums of all variables. This is a sum of two variables, and unfortunately the function is three variable function. So there's a variable z missing here. So we have to expand it into variable z. So this is what we're going to do. We're going to add 0 in form of z times z prime. As you know, variable times its prime is 0. Variable times its prime is 0 right here. Variable times its prime is equal to 0. So we're going to use the second distributive law, take this and break it right here. So let's look at this. So we're going to have the following: x plus y plus z and x plus y plus z prime. Okay, those are max terms, definitely. So we have to recognize what max terms are we. For max terms, binary method works like this. If max term is unprimed, you put 0. If max term is primed, you put 1. Alright, so it looks like we have the following max terms. Max term 0 times max term 1. And this is product, that means we have to use pi, which denotes the product in mathematics. Product of max terms 0 and 1. And that's our answer right here. Let's see if we did it correctly. Let's check. Here we go. Okay, we're doing well. Okay, let's continue. Interesting thing is as follows. Let's look at this. You see this? When you express the same function as the sum of minterms, you get this. Or the product of max term, you get this. So look at those subscripts. 0, 1, 2, 3, 4, 5, 6, 7. That means when you find the sum of minterms, you automatically find the product of maxterms, because as you see, sum of minterms and product of maxterms are at complementary relationship. I'm going to look at it underneath. Okay, so let's look at this. If you have a max term x, let's say max term, let's say you have the following: a plus b prime plus c prime. Okay, when you prime this function, you're going to have the following: a prime b c. Now, this one is this thing is max term 4. So this thing is max term. No, this is max term 3. And this is min term 3. So as you see, if you prime max term, you get the min term. If you prime max term x, you get the min term x. If you prime min term x, you get the max term x. So this is complementary relationship between min terms and max terms. If you prime the max term, you get a min term of the same subscript. The same applies to the Boolean function. That means sum of min terms and product of max terms are in complementary relationships with the same function, which we saw here, right? We saw it here. The function is expressing sum of min terms and product of max terms. This is very important. We're going to use this later in the lecture. All right, let's look at this. Find product of max terms for the following function. It will be very difficult to find the product of max terms here. You have to break those products, both of the products, and expand it into product of max term, which will take a lot of space and time. So we're going to do a different way. We're going to expand this into sum of minterms, and then, knowing complementary relationship between minterms and maxterms, we're going to convert it into product of maxterms. So let's do it. Sum of minterms. So we'll develop it into sum of minterms. So x, y, z prime, and I see w is missing, so I'm going to multiply this term times 1 in form of w prime plus I'm going to do the same with the second term, except I'm multiplying it times y plus y prime. I'm going to foil the parentheses and see what happens. It's while foiling parentheses, I'm going to order those terms alphabetically. So w goes first. W x y z prime. Okay. All right. So I expanded those two terms into the missing variable in w and y. Okay, now we have 4 terms, and those terms are minterms, because those are products of all 4 variables of the function. All right, so let's recognize those. You recognize minterms as follows, using binary method. Unprime variable is 1, prime variable is 0. Okay, so let's do that. This is 1, 1, 1, 0, that's minterm 14. 0, 1, 1, 0, the next one. This one, 0, 1, 1, 0 is minterm 6. Next one, 1, 1, 1, 1. Oh, we have minterm 15. And the last one is 1, 1, 0, 1. 1, 1, 0, 1, that's minterm 13. Okay. All right, so this function can be expressed as a sum of minterms 6, 13, 14, 15. Okay, we got somewhere, but the question is the product of maxterms. So we found the sum of minterms right here, and oh, that's an ugly. We're going to erase this. All right. So we found sum of minterms right here, and this one is equal to the product of the following maxterms because of the complementary relationship of the minterms and maxterms: 0, 1, 2, 3, 4, 5. 6 is a minterm, that means it cannot be a maxterm. So we're skipping 6 and do 7, 8, 9, 10, 11, 12. 13, 14, and 15 are minterms. So this is the relationship. If you have a sum of those minterms, you have a product of this maxterm. That means our answer is right here. That's our answer. Right, answer right here. And that's it. Let's. What else do we have? Why would I want to prime function to find maxterms? Let's see. Why would I want to prime my function to find maxterms? Let's look at the next example. All right. We have the following function. Very easy, x prime plus z. Now this is 3 variable function. You want to find the minterms. So the problem here is you're missing a lot of variables here from x prime and a lot of variables in z. So you have to expand it a lot. What I can do is I can take x prime plus z and prime it. Priming means changing all variables into opposites, complementary. So you see x prime becomes x, z becomes z prime. And the operator plus becomes product. So my f prime is equal to x times z prime. So x prime plus z becomes x times z prime. This is very easy to expand into minterms, only because we have only one term and only one variable missing. So one variable missing is y plus y prime. So we're going to multiply xz prime y plus y prime. So we're going to have the following. We're going to expand it into minterm 6 and minterm 4. This is minterm 6, this is minterm 4. Okay, we're expressing f prime as sum of minterms 4 and 6. Now, we are looking for sum of minterms of this function, not its prime. So if the prime of the function is sum of minterms 4 and 6, that means function itself is sum of minterms complementary subscripts. That means we have a function of which is sum of minterms 0, 1, 2, 3, 5, 6 is not here, and 7. So f prime is equal to sum of 4, 6. So f is equal to sum of 0, 1, 2, 3, 5, and 7. So we found the minterms right here. Now Maxterms. Let's see this function, product of Maxterms. So it's almost a Maxterm. It's a sum of two variables for three variable function. Y is missing, so we're going to add y 0 in form of y times y prime. So x prime plus z plus y prime. I'm going to use distributive law. And I'm going to do the following. I'm going to take this term and break this product. So y goes into the first parenthesis right here, and y prime goes here. Alright, so we broke this product into separate parentheses. Alright, so x prime and z go here, x prime and z, x prime and z. Alright, we're looking good. Alright, so this one is Maxterm 4. Why Maxterm 4? Because when the variable is prime, you put 1 above it. 1, 0, 0, 1, 1, 0, Maxterm 4, Maxterm 6. If this function is a product of Maxterm 4 and 6, that means the same function is the sum of minterms of the complementary subscripts. Alright, and as you see, this matches with the different ways, and we got the same results. Alright, this one, sum of minterms and products of functions. Okay, so what I would do, just expand it into sum of minterms, because the function is a heavy product right here and heavy product right here. So it's very easy to get the minterms out of this product. Let's look at this. So our function is equal to red. We will need red. Now let's change it into black. So our function is equal to red. All right, it's equal to a prime cd. What is missing? B is missing, right? So let's put b plus b prime. So multiplying function times 1 and plus a prime b prime b. And what is missing? C, right? Okay, so let's put 3 plus c prime. All right, let's expand those parentheses, and we have the following: a prime b c d plus a prime b prime c d plus okay, looks like we have minterms. Now let's find what minterms are this. So this minterm is 0, 1, 1, 1. Oh, minterm 7. This one is 0, 0, 1, 1, and so forth. So let's continue with this here. So 0, 1, 1, 1 is minterm 7 plus 0, 0, 1, 1 is minterm 3. And this one, the third term is 0, 0, 1, 1. Same. Okay, plus minterm 3. And fourth one is 0, 0, 0, 1, minterm 1. Okay, so we have the following. We have minterm 3 that repeats itself. So we're going to cross out one of the repeats because m3 plus m3 is just one m3. Like a plus a is a, minterm 3 plus minterm 3 is just one minterm 3. So now we have the following. Sum of minterm 1, 3, and 7. 3, 7. And this is our minterm 1, 3. Okay, now product of maxims. It would be very hard to develop into product of maxims, but knowing that this function is equal to sum of minterm 1, 3, and 7, we know that if the function is equal to sum of minterms 1, 3, 7, that the same function is equal to the product of the complementary maxims. That means 0, 1 is not here, but 2 is here. 3 is not here, but 4, 5, 6 is here. And because this is four variable function, that means it has 16 terms. So it doesn't start with 7. It will go to 8, 9, 10, 11. So 7 we skip, we'll have 8 all the way to 15. Alright, so this is our answer. Okay, now let's look at a few more examples. Very simple. Looks like we have to find max terms of this function, and we can use any method we want. Okay, three-variable function. Any method we want. We can use minterm expansion. We can use maxterm expansion. We can use inverse. You can use inverse function. But looks like the best idea here is to use maxterm expansion, because we have this term right here can break this right here, and let's break this. Okay, so we have the following: we have two parentheses, x plus y plus x and x plus y plus z. All right, looking good. X plus x is x, so we're going to rewrite it. So we have the following: x plus x is just one x, so we have x plus y. And guess what? X plus y plus z is maxterm 7. No, maxterm 0. It's already maxterm, x plus y plus z. All right. The first parenthesis, first term is not the maxterm. You have to expand it into variable z. So we're going to do the following: x plus y plus 0 in form of z times z prime. Okay, and we copy the second parenthesis, second term, x plus y plus z. All right, so let's do the following. Let's take this and break up the product. All right, let's do it. So we have the following: x plus y plus z, x plus y plus z prime, and we're going to copy x plus y plus z. Here we go. All right, so we have the following. Now, look at this x plus y plus z right here and right here. This is a repeat, so we're going to cross out one. So we have the following. This max term is maxterm 0, m0. This max term is maxterm 1, 0, 0, 1, maxterm 1. So times maxterm 1. And that is equal to product of these two maxterms, 0 and 1. And here we go. Here's our answer. How cool is this? Okay, let's, here's our answer. right here. All right, we're doing good. Two more maybe. So let's see. We need the max terms right here. We need to find max terms again. Okay, there are almost minterms. Almost. The first term is missing one variable to become a minterm. Second term also is missing one variable, and third term is already a minterm. So let's expand those first two terms, this and this, into minterms. All right, so let's do it. So that is equal to a prime b c. Now this one is missing d, right? So I'm going to multiply the times d prime plus d, right? So it's a prime b c and d. All right. Now this one is missing c, so I'm going to multiply the second term into c plus c prime. So that will give me two terms, ab prime c prime d plus a b prime c d. And I'm going to copy the last term, a b c prime d. Okay. So I have 1, 2, 3, 4, 5 terms. This minterm is minterm 6. Why do I know it's minterm 6? Because I know that I have to put 0 when the variable is variable is primed. That's for minterms. For maxterms, it's opposite. 0, 1, 1, 0. Right? And this one is 0, 1, 1, 1. So let's do it. This one is maxterm 6. All right. We have a red pen emergent. That's fine. Plus maxterm 7. Plus this one is minterm, sorry. Oops. We have to erase this. Hold on. I got ahead of myself. So those are the minterms, not maxterms. Alright, so not a big deal. Alright, so this is minterm 6 plus minterm 7 plus minterm 9. This is 1, 0, 0, 1. 1, 0, 0, 1. This one is 1, 0, 1, 1. That's 11. Alright, plus minterm 11 plus 1, 1, 0, 1. That's minterm 13. Minterm 13. Alright, let's put it in a canonical form. You know what? Let's use the black one. Why the black doesn't work? Let's see. Let's use the black one. So it's a sum of, let's order them numerically. So it's a 6, 7, 9, 11, 13. All right. The problem is we have to find maxterms. So if we find minterms, we kind of automatically find maxterms. So maxterms will be product of 0, 1, 2, 5, 8, definitely 10, 12, 14, and 15. All right, so this is what we were looking for. All right. Now let's look at the following. Okay, we don't have any. All right, so let's look at this. If you have the following, you have to find the max terms. And you have the following, sum of minterm 0, 2, 3, 5, right? That's lousy, so let's do a redo it of 0, 2, 3, 5. Right? And you're asked to find the max terms. So obviously, using the complementary relationship between minterms and maxterms of the same function, you would write the following. That's if the function is sum of minterms 0, 2, 3, 5, is the same function is a product of maxterms 1, 4, 6, and 7. And that is the answer. Okay, let's go one more. Let's do one more. So let's establish question number 4 of x, y, z. What if you have something like this? Function is sum of minterm 2, 3, and 5 plus sum of minterm 0, 1, 2, 5, and 7. Okay, so you have two sets of minterms. Now, as you see, some of the minterms are repeats here. Minterm 2, so you're adding these two sets of minterms. Minterm 2 repeats itself, so what you can do is you can just cancel. Minterm 5 repeats itself right here. So the answer for this will be sum, just one sum of minterm 0. Minterm 1 would be in a function if you add these two sigmas, minterm 2, minterm 3, minterm 5, and 7. That would be the answer for that. Okay, you know what? Looks like we did a lot of work today. Alright, so we're going to finish now, and I see you next time.